It will actually first exchange a set of empty DD packets. We call it empty DD. In the interaction of the first group of messages, there is no summary. It only uses some parameters to elect the master-slave. Then it will be decided who will start sending this summary first. It will carry a serial number inside. Is used for confirmation. But the question of reliability. Too far away for us now. In the process, we use the DD message to exchange information summary. Then when the summary of the information is now complete, we're going to start making requests next. You can see that R1 does not have this 789 locally. It wants to ask. This is the request. For example, now R1 is about to start sending packets. The packet it sends is the LSR packet. So what will be in this message? R1 now wants 789 from R2. Such as a certain moment. The device wants to initiate a request first. Then it requests an LSR packet to R2. It now wants 789 in R2. Then it also sends a digest. For the whole process of interaction now. Actually in the exchange state. In the state of xstart just now. We will go to the election of the master-slave relationship. Then interact with DD messages. Further down is the LSR. R1 starts the request. When this request message is sent to R2, it should reply to R1. R1 now takes these directories to tell R2. Then R2 should tell me the detailed LSA to R1. R2 will now reply. It will reply this information to R1 here. When R1 receives, it needs to send a message to tell R2. It received the message just now. It will send LSAC to R2 at this time. It means that it has received the message sent to it by R2 just now. This process is actually called exchange. The device is in the process of interacting with the whole. Is in this state. Then start the database synchronization. Finally, all the equipment is completed. Of course. This thing is actually. R1 local synchronization is complete. It sees the opponent as full. So, how to switch to this state? There are many parameters in it. When you reach the NP stage in the future, just sort it out slowly. Okay. Let's make a summary. The first is the hello packet. The hello packet interacts in the first three states, which is used to establish neighbor relations. From down to init to two-way. The difference is that check if there is a router ID with it inside. If it receives a hello packet with its router ID, it is two-way with the other party. If it is not received with its router ID, is init. Here are the first three messages. The first three states use the hello message. Let's go on. DD packets will be in xstart and exchange state. Carry out the election of master and slave. To represent when the device is syncing. Who initiated. And confirmed during initiation. Confirm each message sent. Then it will complete the master-slave election in the state. They can start to interact with the corresponding directory. They are the DD message interaction directories. Used in a one-time state. After interacting with the directory, they are in loading state. Is about to start making requests. Replying. And finally confirmed. Is requesting information that it does not have. Then the other party replies to it. It sends another confirmation to the other party. This is what we call loading. Then in this state, as long as it's done, it will switch to the full state. That is, it sees the other party as full. For R1, it requests 789. The other party replied to it with 789. It returns confirmation to the other party. Then it ends in the loading state. It will see that the other party becomes full. Why do we often watch the two achieve full at the same time? Because this process takes about the same amount of time. I ask everyone to master the following content in the NA stage. First, grasp the hello packet to establish a neighbor. DD packet interactive directory. These are request, reply, and confirmation. You need to know their names and uses. Then I tell you now. When between two devices. When the mutual status of the two interfaces reaches full. Now called adjacency established. This is the key. If between two devices. Only established neighbor relationship. So can they realize the calculation of routing? Okay. Is not possible. Because they are neighbors. No information exchanged at all. So, the neighbor relationship is just a confirmation of the relationship. It means that they are running OSPF on a network segment. Nothing more. They do not have any interaction with the database. So it has no way to calculate the route. And after they finally reach the full state, their adjacencies has achieved database synchronization. As they are now requested, replied, and confirmed. Both of them are now 1, 2, 3, 4, 5, 7, 8, 9. After all sync. Route. Make sure they have all the network segments now. So when they reach the full state, in order to continue to use the SPF algorithm to calculate the corresponding route. Some students may ask, how do these two relationships work? Let's take a look here. Router ID. Neighbors and adjacencies. Let's take a quick look. For now, the device runs OSPF. They all have to exchange some information. Link state information and routing information must be exchanged before the interaction. Adjacency. Everyone can see. RA says it has 3 neighbors. Remember this? What does it mean to connect 4 devices with one line? I said before. This means that a switch is connected to 4 devices. But we usually don't draw this switch. That means they are on the same network segment. If on the same network segment, they are neighbors. But they are not all contiguous. Depends on network type. We are network types of Ethernet. There are 3 neighbors here. But you can't say it has 3 adjacencies. We can't see what it is now. These parameters are not enough. We can't see now who is adjacent to whom. Just to tell everyone it has 3 neighbors. But not with 3 adjacencies. Let's move on to a question. I will draw a picture. For example, this is a switch. It connects several devices. Connected some routers. This is 4 devices. Haha, a little ugly. Let's say it's 1.1.1.1. This is 1.1.1.2. This is 1.1.1.3. This is 1.1.1.4. Now 4 devices are interacting. Assume that the 4 devices are adjacent to each other. That is, between 2 is full. Let's see what kind of effect will appear. Let's take the device on the far left as an example. For the device on the far left, we have to consider a DD message. DD packet is a unicast packet. I'll just give you an example. For example, all devices are adjacent to each other. The database is synchronized between the 2 devices. So now you have to consider a question. There must be an interaction between the 2. Suppose the leftmost device originally had a 1-2. It has a 1-3. It has a 4-5.